Okay, are we ready to start? Everybody here? Nice. Okay, let's do it. Okay, welcome. Welcome to week 2, day 4. It's a Thursday. How's everybody feeling? Silence, love it. You guys have been spending yesterday on a bunch of networking stuff, a bunch of async programming, dealing with callbacks, dealing with timers, things like that. How has that been going? Fun? Yeah? Had fun with the snake game over there? Nice. So today, you're going to continue along that path. You're going to keep working this week on asynchronous control flow because it's such a big, big part, not only of web development in general, but also of the language that we're learning with, JavaScript, that it's just going to be something we need to get comfortable with. And as we've said before in Compass, it takes time to get comfortable with asynchronous control flow, so don't expect by the end of this week that you're like fully, oh yeah, I fully get callbacks and I can write async code no matter like how difficult it is. It'll take some time. So today will be kind of split for you in terms of what you'll be working on. You'll be doing a little bit more in the HTTP, API, that kind of stuff, and you'll be learning more about web development. But then about halfway through the day, you'll get deeper into more conceptual stuff, which is what the lecture is on, which is promises. So we'll be actually spending a lot of the lecture, in fact, the entire lecture, talking about asynchronous programming, not about some of the other stuff early on today, like APIs and JSON and stuff like that. I'll leave that to Compass and the activities that you have today to get going into that. And today, for our lecture, we'll just be focusing on promises because it's a beast of a topic. So a little bit of expectation setting before we get into promises. They are a little bit daunting at first. They seem a little bit abstract and confusing. And I know for myself as a developer, it took me a while before I fully understood what they were all about, like why they existed, what problems they were trying to solve. All of that stuff took me a little bit of time to understand. And that was after having completed a computer science degree where they weren't talked about at all. So definitely, it will take you a little bit of time. Now, of course, we're teaching it a lot differently as well. And they're a lot more prominent now than they were before in web development. So you have that going for you, which is nice. But again, when it comes to stuff like this, don't expect that by the end of the day, after having spent, let's say, about half a day on promises, that you'll feel fully comfortable with them. Okay? It will take you time. And practically every week that follows will get you to use promises in some way. Okay, so it's, again, just like things like callback or some of the focal stuff from week 1, it's foundational, and it will take time for it to fully solidify. Oh, I didn't start off with a joke. This one's another traditional nerdy programming joke in line with asynchronous control flow. Here we go. Actually, I'll write it down. It's actually better written down. It's like 4 words. Knock, knock. Or rather, who's there? Knock, knock. Backwards. It's a timing issue. All right. Enough of that. So what we'll do is we'll actually look at, instead of, again, just being like, here's what promises are, and talking about their definition, I'm going to take a different approach like I normally do with lecture, which is to start off with a problem. And we're going to solve that problem without promises, using the way that we know already how. So that'll be a little bit of a review in terms of async control flow. And then we'll solve them using promises. So we'll be able to relate to the before and after. But one caveat I'll say is that the problem that I'll show promises solving isn't the only problem that they solve. They solve multiple async-related challenges. I'm just using one of them as the most common one, perhaps, to kind of justify their existence and to explain them. But then one of the reasons why they're harder to explain and harder to learn is because they solve multiple problems. Okay. So what we're going to do is, classic problem. We have a bunch of data. In this case, it'll be in the file system, so it'll be local files. I have them in the data folder here. Okay. And these files are just text files. We're going to keep it simple. We're going to use the FS. You're familiar with the FS module in Node to read files. Okay. But the challenge that we have in front of us is that we have to read them in order. And we have to create one final string, or document, if you will, as a result. Right? So we're simulating a real-world problem, which is quite common, We have a bunch of data out there, whether it's on HTTP or on file system, doesn't matter. And we have to read it sequentially using a language like JavaScript, which is very asynchronous, right? So it doesn't have a very easy way of dealing with async things like reading from the file system, but we have to do them in a synchronous way. Read file 1, then read file 2, then read file 3, then read file 4, right? What's in the files? So what I did was, I mean, it could be anything. I decided to put in the 4 sentences that make up the Agile Software Development Manifesto. Again, just random for purposes of the lecture. So the 4 sentences are in this order. Individuals and interactions over processes and tools. So Agile is all about moving fast and being quick. So individuals and interactions over process and tools. Working software over comprehensive documentation. Don't spend too much time on documentation. Customer collaboration over contract negotiation. So it's all about people and customers. And responding to change over following a plan. Again, the definition of agility is being flexible, right? So responding to change over following a plan. We're not here to learn about this necessarily, although it is something that comes up quite a bit in software development. So these 4 sentences are spread across different files. It could have been something else. It could have been some more relevant data. Right? These are the 4 sentences. And we're going to be looking at how do we actually read these in order. Okay, and you've done something actually very similar to this already. Does anybody remember which assignment recently this week you worked on where you had to sequentially deal with asynchronous stuff happening? Had to deal with it in order, like first this, then that, but using callbacks? Yeah, the fun profile generator, exactly. Right? It looked like this. Your solution likely looks something like this, where you used readline, not FS, because you were reading from the user input, and some boilerplate code here to set it up. And then this was the actual solution, really, was asking a question, right? And then because we had to deal with callbacks from a JavaScript perspective, we go into a nested callback situation, and then we ask a second question, and so on. And it's essentially the staircase or waterfall or callback hell that we see that's often visualized like this. Right? Does this look familiar? I don't see. Yes? No? Yeah? So how would we implement this solution using this kind of approach? How would we do that? Where do I start? So I've got these files. There's 4 of them. What do I do? Call them back to the different files? Yep. What do I use FS for here? What function should I be using? This one might ring a bell. Now, as I type this, you can see VS Code is being smart and actually giving me 2 suggestions. And you might have come across read file sync, if you recall. So read file sync is going to help us solve this very easily. We don't even have to deal with callbacks, because it actually does it synchronously. It doesn't use callbacks at all. But we're not going to take that approach, because we have to pretend that we're actually leveraging Node in the way that it's meant to be leveraged. And if we just run read file sync 4 times, it will be very easy, very straightforward. It will look like this. Or maybe I have all my data in an array, right? And then I'll basically just take whatever comes back from the file, read it as a text file, UTF-8 encoding, and simply push that into the array. And at the end, I'll have an array, once I do this 4 times, of all 4 of those sentences, right? So I'd simply copy paste that 4 times, or loop through, right? And just change the file name each time from P1 to P2 to P3 to P4. Fairly simple, right? But and this may be a good solution for a script that we're writing to run in the command line. It's okay, because it doesn't really need to have multiple users trying to access it at the same time. We don't have that problem. Whereas in web development, when we're running a Node server or JavaScript server, it's going to be getting a lot of requests coming in from users, right? That's what a website or a web app does. And in that case, this solution will fail or will not scale because each of those reads is blocking the entire Node process and not actually able to handle other requests at the same time. So you have to kind of make a decision. It's not like this exists and you should never use it. You should just use it when you don't have to worry about concurrency, right? Because all this callbacks and promises stuff is about handling concurrent things at once, dealing with many users at the same time, or many tasks at the same time. Whereas if you're just running this as a app that you run from command line and it just is supposed to do these things, that's just one user running a command. That can just be using read file sync. So we'll have to pretend that this is not a script. We'll have to pretend that we have that real world concurrency problem, that this is a web application that we're building. And so we're going to use the non-read file sync version. We're going to use read file that we're already somewhat comfortable with, because you've already done some stuff with read file, right? Yeah. So what does read file return? Read file sync returns the actual contents of the file. What does read file return? Does anybody remember? If you don't know, we can try it out. Let's see what happens. It's good to have a hypothesis. It's good to have an assumption of what will happen, and it's okay to be wrong, as I've said before. So does anybody want to guess what data will be equal to? It will console like the contents of the P1 text file. Well, what I said was that that will be the sync function, the one that actually goes ahead and reads it without callbacks. But we know that we'll need a callback here to actually get the data out. So it's likely not the data. I've misnamed it intentionally. What is it actually going to be? No guessers? Yeah? No? Or no? You don't want to guess? You don't know? Yeah? Well, what am I reading here? I'm reading a text file specifically, right? So I'm not reading the contents of a directory, which is where you might have the, well, are there other files in here? Is it an array of files? This is specifically targeting that file and reading it. So it's just whatever the contents are in there that we're trying to read, but I'm arguing that that's not what's going to come through here. It could be the properties of the file, but even that is something that takes some time for Node to run, right? Because it needs to use the disk, which may be slow, to actually fetch that information, or the file might be very large. So that's ideally async as well, right? So that's probably coming back through to us using a callback. I have yet to pass in the callback, so I'm not fully using this function yet. A string with inline characters? What do you mean? 9 characters. That's 9 characters. Ah, why is that? Because that's a test file, right? It's a test file. It only has a few characters in it. I don't know exactly how many, but those, right? But I'm telling you, it's not going to return that. It's not going to return the string from the file. Empty string is a good guess, because it doesn't have data for you yet, right? The data is actually going to be in the callback. So if we were to have a callback here, I'm just going to put in a, sorry about that. I'm just going to put in a empty callback here for now, just so that it actually still works. But I'm curious about what it returns. What does this function actually return? Okay. Any other guesses before I run this? Yeah? Also a good guess. True or false is a good guess. Why do you think it would be true or false? Yeah, maybe like, is it going to be able to find the file successfully or something like that, right? As it turns out, that's wrong, but it's a good guess. I'll tell you why in a second. So let's run this. So what did it return? Undefined. Why did it return undefined? Which really tells me absolutely nothing in terms of what happened, or will it be successful or not, or details about the file, or what's inside it, or anything. It basically is completely useless return value. Why? Yep. Because the entire operation is asynchronous. In fact, even the true-false, for it to know that, it actually has to start reading from disk. And so even that would require blocking the entire node process, and something that node recommends that it doesn't do, that you don't do. And so for using the asynchronous function, it can't do anything. It's queued a task somewhere to go ahead and read that file, but immediately returns with, OK, cool, now what? Right? Like it's ready to move on while that task is still queued to happen and may be happening right away. But it may take a few milliseconds. And so it's ready to move on. If we have a console log in here, and we have a console log, well, we have a console log right there, right? Which is after the function call. Which one will execute first? After. After will execute first because the function immediately returns, going here first, and then at some point that task to read the file will kick in. And then the callback will be triggered for us, right? This is kind of a little bit of review on how callbacks in asynchronous control flow work, right? After first, and then it triggers the callback. Now we know that data is really useless to us, so might as well get rid of that, right? There's no reason to look at the return value of read file. And we don't need to output that either. In the callback, there's going to be some parameters I can use to accept the data. But another pattern that you might have already gotten comfortable with in Node is that there's 2 arguments in a callback that's asynchronous usually, at the very least. And the first one is error. The second one is the thing you want. Do you recall this? Why is that the case? Why is it that Node hasn't, the data is clearly more important. Why isn't it first? Another review question. Why is error first? Yeah.
So let's say you have a logic file. If it were to fail, it's going to fail before you read the whole thing.
That's true. It's a good guess. So you're saying like errors will happen before you get the full data. So logically, you'll have the error first before you have all the data. It could be a really large file, like 2 gigs or something. But this function only triggers when it's read the whole file. So at that point, it knows, or fails to read the whole file, right? So you either have all the data or you have an error. So it could be flipped still. The argument order doesn't really talk about the order of operations. It's kind of like order of importance, right? Are errors more important than the data? I would argue no, the data is more important. But maybe I'm wrong?
Is it because you'd want to know if there's like something immediately wrong with the file before you even get the data so that you don't get anything that's left out of the data?
You're onto something. If it was flipped, where the data was first, I could just do this. Because in JavaScript, with functions, you can just ignore ladder arguments. You don't have to accept them. You know that this callback will be called with, let's say, 2 arguments, the data and the error, but you only care about data. And so you're just going to accept the first argument, and that is not invalid syntax. In other languages, it might be, but in JavaScript, it's totally kosher. So it promotes this bad practice of like ignoring errors. You see, I've just ignored the error, if there was one. I have no idea how to check for it. And so it's promoting this bad behavior. So the Node community decided, you know what? What we'll do is we'll make sure that the errors are the first argument so that you have to explicitly at least accept that argument, even if you're not going to check it. But you really should be checking for errors, right? What if it didn't work? So that forces me, in order to see the data, I need to accept the error as well. And then let's just go ahead and console log, I guess, both of those things. And what do I expect to happen here? What do I expect to see? Awkward. awkward pause. Error to be null, because we expect that that file exists, and data to be the string that was in the file. Yeah, that seems reasonable. Looks like you're right. Awesome. And if I were to have a file name that didn't exist, we see that error is actually an object, right? And yeah, that's a good question. Why is error null here? It could have been undefined as well. You know, it could have been empty object. They decided to go with null. But the more important thing is that there is no error, right? And null is a falsy value. So we can just say if error, and it should be truthy, which is an object is truthy, the existence of an object. And so we can just say if error, instead of if error is equal, triple equal undefined. We don't have to do that. We can just use truthy falsy, right? So what I normally put in here is, as a next step, is if there's an error, right, then we want to just decide to stop, because there's no point in reading file 2 if file 1 is a problem, at least in our current problem, right? In our current scenario, we have to read each file in order, and if one of them is not working, then we just give up. So here we would just give up, maybe use return to just, you know, we console log and return maybe. Something like that. And the reason I use a return there is so that I don't have to do an else. That way I can just keep going right in this function, because it will either return and completely stop there, or I can just keep going after the if statement, right? And we can maybe even include the error in the console log so that it's like, what was the error? Let's try that. So works fine. We have the one string. It's not exactly what we need just yet, but we're working incrementally here. And if it was, you know, a file that doesn't exist and leads to an error, we'll just see, yikes, failed to read P1, and then the actual error details. Any questions about this so far? It's a review, but I want to make sure we're feeling comfortable with this. Yeah? OK, but remember that my final goal is to have this eventual string, or at least an array of strings, that I can then join to create a final string. Because I want all 4 of those sentences in order as my final output. So what do I do next? Read the second file, of course. I could read the second file right here, but that will be problematic. Why is that? Why is it problematic to read the second file in the exact same way and in the exact same indentation level as the first one? Yep, Peter? It can be read at about the same time. Even though that task is being queued, if there's 2 tasks being queued, right? Task 1. And then below that, right away, before this even has a chance to complete and read from the file system, we queue another task to read file 2. So you'd think this one will run after this one, which is fair. This one will start running, then this one will start running. But that doesn't guarantee that they'll finish in the same order. What kind of things would make them finish in different orders? Yeah, exactly. If file 2 is really small and file 1 is like really large, you have no guarantee. I mean, I can guarantee actually that one will finish before the other in the opposite order. Right? The smaller file will finish first. It finish reading that file quickly. Right? And so we want them in a specific order, and what will happen in this case is that we're actually going to end up reading the shortest files first, not that particular order that we want. So instead, we know that we have the file data here in this callback from the first file. So we would put a call to the second file. I'm just going to copy actually all of this and place it inside of here as an indented solution. Now instead of P1, we're going to read P2. And so what we have now is, hopefully that will work. There's no typos there, and the files do exist. So what we'll have is 2 console logs with P1 and P2 in order. What I'll just do is label them accordingly, so it's easier to see. I mean, I wonder what would happen if I hadn't done this. Let's see. Move it out again. This is the approach that we said we weren't going to take, but let's just try it. It seems to work fine here, right? But what happens if P2, or P1 rather, is really long? Still seems to be working as we expect. At what point, solid state drive, things move a little bit faster, but at some point, the file is large enough that the order will be flipped. I just can't simulate it here very easily. Now, we're using file system, right? And so things are generally like, we kind of know how long things will take. Like if I ran a benchmark, I would know how many milliseconds it would take to read a file of that size. But I'm specifically using an example that uses a file system and doesn't use what you'll be using today with promises, which is networking calls, right? HTTP calls. And as you can imagine with HTTP, because you're actually making a call to like another server somewhere else, who knows, in a different country, that's going to take a lot longer, and the speed of that is going to be quite variable based on so many different factors, right? Your own Wi-Fi connection, your own building's internet connection, the actual server, where it is, how far it is, whether that server is just bogged down that day or that particular minute. All of those things are going to factor into how long it takes to get that file back or that HTTP response back. But I didn't want to use HTTP here because you're going to be using that for your assignments today. And I want to kind of use file system as another example that you won't get as much exposure to today, right? OK, so let's move this back into inside this callback. Close that out. And I'll have to use another callback here. This one here is where I'll put in the third callback, right? The third file read will be in here. In fact, before I do that, why don't we actually start collecting the data? Because we're going to need to output it at the very end. So I'm just going to, instead of console logging, or just console logging, I'll do final doc.push data. And also, it's not really ideal that I have data here as an outer variable. And then inside this same scope, I have another callback with data. Like, the naming is just getting confusing for me, because I have different values in data each time. So maybe what I'll do is I'll rename this to be P1 or P1 data or something like that. And that way, it's very clear that I'm like, that's file 1, right? P2 over here, and so on. Let's run that to make sure I didn't break anything. P1, I need to make that file simpler now. There was no point in that. OK, so there it is. Now I need to do 2 more files. So I'm going to need to copy this and paste it in here. After pushing P2 into the final doc, we can run it for P3. And then once more for P4. reading the files in order. And now, in that final callback, if I console log final doc, because I've added all 4 of those items in the array in that order, I expect to find an array with all 4 of those strings in that same order that I used for console log. Agreed? So let's just make sure that's the case. It is. And of course, I'm supposed to actually like output this, I guess, for now. So we could output this by joining the strings with maybe a new line each time. So that's our output right there. Okay, so this is a non-promise-based approach. And we see the same callback hell that we saw with the, what was it called, the assignment again? Fun profile generator, right? Where you had to ask a bunch of survey questions. And then at the end, generate a profile for them. What kind of challenges do you see with this approach? There's obviously the one that I've already highlighted, which is the nesting of things. Are there others that you see as potential challenges here? Hard to debug? Yeah. In terms of like when there's an error, how do I actually, first of all, recovering from errors is a little bit harder because I have to do error handling at every step, right? And then it's also hard to debug like where things are happening because it's so much nesting happening in terms of callbacks. What else? Any other issues with this? Yep. Yeah, it doesn't really scale well for like a dynamic number of files. Like how do I loop through files and do this? Right? I'm not just doing it in the same indentation. So I can't just easily introduce a loop here for an array of file names, let's say. Makes it tough. So yeah, those are some of the challenges that come with this. We're going to try and tackle those with promises. So let's talk about promises. I have another file, so this one's going to obviously be in the notes as well, which is where we're going to solve this using FS again. But thankfully, more recently in Node, there's an experimental module called fs.promises. So it behaves a lot like FS, but A, it's experimental. They suggest that you don't use it in production. But again, I'm not here to teach you about that particular module. It's more about how do we use promises, right? But I just want to quickly bring it up in the documentation. So that would be node fs promises. And you'll notice that on the same page where Node talks about FS in general, or file system in general, things like read file is right there, or read file sync for that matter. It also talks about promise-based approach. So that would be FS promises API. And so it's kind of like a sub-module, if you will. And in it, we see that there is still the same functions, read file, write file, things of that nature, right? Read directory. So let's open that up. Where to go? Right there. So same thing, asynchronously reads the entire contents of a file. Great. It does the exact same thing that we need. Let's actually play with it. I mean, we kind of know how to call this function, right? And we know that it uses promises. We don't know what they are yet. And what I'll do is I'll pretend that I'm learning promises kind of through using this API. Okay? So what did we do last time? We said fs.readFile, and we gave it the name, the path to the file. And the second string was the encoding. And the first thing that we did was we said, let's look at the actual return value of this function. What does it return? As it turns out, this will not return undefined anymore. Let's even call it maybe P1, since that's the file that we're reading. Guess what? Can you guess what this will return? I can tell you it won't be the data again because it's an asynchronous operation. So we do need to use callbacks to deal with that. So it won't be the actual contents of the file in P1. What will it be? Any guesses? No? Aside from the warning that we get from Node saying experimental, this API is experimental, so that we can ignore. We're actually seeing our output from that console log, and it is the word promise, curly brackets, pending. What does that tell us? Specifically the curly brackets, is that a hint? It's an object, exactly. So what's actually coming back, I'm going to erase this here. Eraser. Eraser. Forgot to set up an eraser. This will serve as an eraser. Actually, here we go. This will be better. So, interestingly, what's coming back is a promise. So what's interesting is they said, okay, well, we have to deal with these asynchronous things that are happening, and results are coming back in the future, right? It takes a little bit of time. So instead of actually giving you nothing back, which is what we saw with read file, and then getting you to use a callback right then and there, they said, why can't we separate those two tasks out? Why don't we actually give you back an object? And objects can have methods. They can have functions on them, right? So we can still have behavior on these objects, such as attaching callbacks, because we'll need to work with callbacks still. But why don't we separate it and actually have an object where you can work with callbacks? And that object kind of represents a promise that this will actually run, and hopefully return the results that you want, because it could also be an error, of course. The file could be missing or be broken or whatever, just like before. So it's a promise of a task being completed, or it's a promise of a value. And the analogy that's often used when promises are introduced, as you'll see today, is the analogy of when you go get a mortgage or a bank loan, where the bank will actually, when you go and you apply for that loan, specifically mortgages, which are like larger loans, they don't just give you back undefined, because they will need time to process that loan. So they don't know if it's going to go through or not. But what they can do is they can give you like a document that says, here's like your loan, and here's like a pre-approval of a loan, right? Like we've done a little bit of work here, and we know that like it's likely going to go through, so here's the document that actually promises the money. And unless there's some kind of like weird disaster where like the bank has gone under or something like that, that money should come through, right? Why is that important? Because we're actually able to take that promise and action it later. We're able to action it actually right away. We're able to take that document and start like looking for homes and being like, look, I'm actually like eligible to buy this home because I have a promise from a bank that I can actually afford this house, right, through this mortgage. And so we're actually able to take that piece of document, that object, and action it right away, even though it's going to take time for that money to come through, and there is a chance that it doesn't. Same idea. Now, you'll notice that inside the curly brackets it says pending. So one of the things that's interesting about promise is that it goes through different stages. And as you can imagine, the first stage of applying for a loan is that your application is pending, right? So the promises always start in the state of pending. And then there's essentially two major things, right? Either it's pending or it's completed, right? And so I guess I'll use blue for this as well. It's somehow going to transition when the task is complete. In this case, the file is being read from the disk to a state of essentially fulfilled. You can think of that as completed as well. That's another synonym for it. The word that they like to use mostly around promises is the word fulfilled. Your promise has been fulfilled. So there's going to be kind of a transition one way or the other. Now, how the hell are we going to actually know that the promise has been fulfilled? Right? We still need to work with callbacks here. So instead of attaching a callback right here like we could before, this particular function, because it's part of this submodule, does not take in a third argument, does not take in a callback. Because it returns an object, which is a promise, and all promises behave this way, they actually give you a function to attach callbacks. So we'll do something like this. Just to see it. Not much has changed in terms of I'm doing asynchronous programming. I'm using a callback. It's just that I have an object now from read file which claims to be a promise, and I'm able to call a specific function that exists on all promises, which is called .then. Right? Which is like when you're fulfilled, right? Then please run this. Yeah.
Can you talk a little bit more about the then? So is that built in all
I will.
objects, or?
I will. No, it's not built into all objects. It's built into all promises. So if the object is of type promise, so if you're using a library that works with promises, because one of the things I haven't mentioned is, but we see it here, I had to use a specific library for promises to work. I couldn't just use FS's traditional read line. I had to use a specific one. And you'll be using many other libraries starting today that specifically in their documentation will say, oh, and we'll return a promise, and we're promise-based, right? So you definitely have to make sure that you're working with a promise, and once you're sure that that library is giving you back a promise object, then you know you should be using .then. Pretty much any library where you're using promises, you'll be using .then.
So there's different types of objects, like a promise object, and then there's like.
Yeah, I mean, a different type of an object is basically how it behaves, right? So is it containing just data? And we've used various different examples before, like instructors, where there's first name, last name, and then maybe a function on them, like a method that gives you back their full name, right? So that's an object. And just a quick review on objects, they contain state and they contain behavior. So state is their first name and last name, for example, with instructors. And the behavior could be any kind of functions or methods that exist, right? In the case of an instructor, it could be, please compute their full name. And that's a behavior that's actually giving you back more information. So in this case, this is behavior, right? We're adding another callback to this promise, or we're adding a callback to this promise so that it can execute it. Because based on its behavior, it knows to execute it when it's fulfilled. And actually, more specifically, .then will only trigger in the success. So that's why that's green. It'll only trigger when the promise is successful, not error. Which is why you notice another difference here with my callback. Notice that there's no error handling. There's no error parameter as the first argument. Remember, from read file, the first argument was error and then data. Not the case here. So this is called like success, let's call it, right? Another term that's used is resolved. So successful or resolved promise, still a fulfilled promise. You know, it did the task you wanted it to do, whether it was successful or not. There's two options, right? Either it was or it wasn't. It's pretty binary, right? See that it's working. We get our value back just like we did with our first read line that we did last time. What do I do next? Well, I can definitely use promises to still have the same problem as I did before, which is I'm working with callbacks. So I can easily just get nested callbacks here, right? I can create a P2 and do the exact same thing. And then P2 would have a dot then. And inside of that, I would have P3, right? And inside of that, I would have P4. So I could still have the callback hell. Promises are supposed to help us solve this. So clearly, there's got to be a better way to leverage them than what I'm just doing here. Question?
Since it's an object, can we just keep adding to that initial object with the promises?
That's exactly the approach that we're going to be taking, or almost exactly. So the question was, can't we, since it's an object, can't we actually not do nesting? And the idea is that that's actually what we're trying to do here. So instead of putting more stuff in here, we definitely want to kick off another task, right? Once this is completed, I want to kick off P2 being read. I'm actually going to do something interesting here with nesting. I'm actually going to nest this like this. Same thing. I've just, because it's the same line, I've decided to nest it or indent it. It's not really nested, it's indented in, so that we can have multiple dot thens. So in this, right, what happens if I, let's say, do this? I'm just experimenting a little bit here instead of going straight to the solution. What happens if I have another dot then? No idea what this is. Let's just call it data as well. It's a callback function. You're familiar with arrow functions. I'm using them pretty casually right now. Hopefully that's OK with everybody. Yeah? What do we expect this to be? And I don't expect you to have the answer, but I expect you to maybe have some guesses. Who said that? Peter? You think it'll be the same thing? It's a good guess. It's a really good guess. Any others? Maybe null is also a good guess, like it already did the thing, there's nothing more to do. Maybe, yeah, that's also a good guess. Yep.
So we're gonna have no output with that line because
Error might be another good guess, like you're calling dot then twice. And what am I calling dot then the second time on? Am I calling it on P1 for sure? Like, what is this actually reading in your head like? Is this all on one line? Because there's no semicolon here, right? If I put a semicolon here on line 10, then this is invalid syntax because I'm starting off a new line with dot, which dot on what, right? What are you calling this function on? So actually, this is continuing from the previous line, just like this line was. Right? It's hard to read this way, so we indent them underneath. So what am I calling the second dot then on? I'm actually calling it on what this evaluates to, whatever is before it. So we actually don't know what I'm calling it on because it really matters what that whole thing evaluates to. Agreed? So let's actually, before we even call dot then, let's actually just console log what this whole thing evaluates to. Shall we? How do I do that? I'll just wrap the whole thing in a console log. Right? And again, the same hypothesis. It could be null. Like a dot then, what is it supposed to return? It's taking in a callback. Should it just return undefined because it's already taken a callback to deal with the data? Could be anything. Let's take a look at what it returns. We'll learn something from this. Let's just make sure we don't have any other console logs. The only other console log we have is this data one, which is right here. So it looks like the dot then returns a promise, which is an interesting, like, recursive type pattern, where like it keeps returning promises, which allows us to do another dot then. right? If it didn't return a promise, it returned some other kind of object or undefined, then I wouldn't be able to say dot then because it would be undefined dot then, which wouldn't work. So the reason I'm able to do this and then say dot then, and I don't know what this is going to be, right? I'm still learning, let's pretend. The reason this function will not error is because I'm already dealing with a promise again, because this whole thing again returned a promise. So you had different hypotheses for what will happen here. Somebody said null, I guess, or undefined. Somebody said the file contents again. Error, maybe, but we know that promise is there, so we shouldn't get a, like, you're trying to call dot then on undefined, so it should not error, ideally. Yeah? Oh, yes, I forgot to do that. That's a good question. What happens if I console log P1 inside here? Because we saw that it was pending. I'm going to comment this out one step at a time. What happens to P1 after the promise has been after the callback has been triggered? Let's take a look. It actually is no longer saying promise pending. It's actually saying the promise has, essentially it's indirectly saying the promise has fulfilled. And it's actually showing the value of what it was fulfilled to. What was the end result? Interesting. OK, so coming back to what I was saying, we are chaining another dot then on this promise that was returned yet again. And we're saying, what the heck's in there? Let's take a look. This one, if I actually didn't know how promises work, I either have to read up on it. It would be hard to guess. So that's OK. What did we get back? Undefined. Interesting. That doesn't really help us, right? We ideally want something else here so that we can continue chaining these dot nens and then avoid waterfall by just having this one level of callbacks instead of a nested level of callbacks. Well, what happens if I do this? I don't know, return hello. So this particular initial callback in the first dot then returns something. Because previously, what was it returning? Undefined. Right? A function that doesn't have a return statement is implicitly going to return undefined. So let's just actually see what happens if we do this. What this will do is it will actually feed hello into the next callback. We're starting to learn a little bit more about how promises work. And already I'm starting to go, oh, interesting. So if I can return a value from the first callback and have a second callback registered that then gets the input from the output of the first one, right? This hello will be fed in. This return value will be fed into data here. Then I can do some computation in the first one, and then the second callback can deal with that computation, right? Whatever data came back, let's say I had to like massage it a little bit, format it a little bit. In this case, maybe turn it into all caps. Then my next callback can have that value in it and do something more with that data. So it allows me to do this like synchronous logic, still using callbacks, with just one level of nesting with dot then, as many times as I need. Right? But there's still a problem, and we'll tackle that problem after the break since it's already 56 after. But the problem that still exists, does anybody want to guess what it is? This still has a problem when it comes to async work, right? What is the, yep, go ahead. Yeah, we still have to make a second asynchronous request because formatting data, like what I just did with return hello, which is synchronous, okay, fine, I can return something synchronous. But asynchronous stuff isn't returned. We use callbacks. So how will I make another callback-based request, just like the first one, using dot then, and not have to go into another nested callback. We still don't know that work. We still don't have that working, right? So I still have to make a call to P2 and hopefully not end up in callback hell, which I could easily do if I don't understand how to leverage promises properly. So there's still another attribute of promises that we're going to learn, but because of timing, we'll learn it after the break. That will allow us to kind of understand how that callback hell is going to be solved with asynchronous requests. Okay? So let's take a 10-minute, and we'll go from there.
I'm serious question with the output data.
With the output?
Can we look at the terminal?
Sure.
For example, like data.
Yeah,
Right,
this is
that's the
data.
first
Yeah,
output.
that I'm not outputting, and of course that I'm not outputting. These two lines here, but the first line is okay. Data, individuals, and interactions over processing tools. That's my P1 data, and that comes from this line.
Great. And how about
And
this?
it's still a callback, just like before, right?
And how about this like console log? How like
That was me outputting the promise object again, right? So this promise object up here,
oh, I got you.
just to look at what is P1 now equal to after the callback has been executed.
After like the stage of the
Yeah,
the
because
promise.
once the callback is triggered, the callback gets triggered here. So I want to see what does P1 look like. Is it still saying pending? Ideally not, because it says .then, and then is only triggered once it's successful.
Great. Can you run it? The P1. The P1 thing.
Yeah, sure. So it should say, whoops, it should say P1. We'll just actually add P1 here, or just promise, right? This is what the promise looks like right now. And before, let's look at P1 before as well. So we see thing, and then we see it change from pending to some kind of a value.
What is not?
Ignore it. Pretend it's not there.
Okay.
Yeah,
Right,
it's
okay.
just there for now. It'll go away in a few months or years or whatever.
Right. And how about the second then function?
Yeah, so the second then function, we were like, what is this? We were trying to kind of figure out how to chain these .thens. And in doing so, we noticed that it was undefined.
Right.
But then when we change the return value of this function, it ends up being the value that comes into data.
Right.
So now data is hello.
Hello. It was undefined because like this function
Was returning
doesn't-
undefined.
Right.
Right, it was returning undefined implicitly.
Right.
So it wasn't just this is how promises work, it was actually a behavior of our first one. Any other questions so far? I mean, there's a lot more to cover here. We're kind of slowly. Yeah, exactly. Exactly.
And what if
Yeah, we haven't talked about errors yet. I will.
okay, so,
I will.
But this one promise okay to run fine for like out and
Yeah, so what actually happens, and maybe I'll do this on the board afterwards as well. A promise object is returned to us, which is of state pending. Meanwhile,
like it means it's still running.
yeah,
It's not. I haven't got the.
Yes, exactly, because we just created it, right? And just like with the other approach, it takes time because there's a queue of tasks, right? I don't know why I drew it like that. There's a queue of tasks, right? And multiple tasks can be added in here. So this task is to read file P1, right? And so when this promise is created, this task is starting to run already. It may take 2 seconds, it may take 200 seconds, it may take 200 milliseconds. We don't know how long it will take.
Even like this one is still running.
Yeah, and this one represents this task. So when this task is finished, it will go ahead and update this promise to be either success or failure. So when this task is done, then I think the screws are gotten loose. Then it will it will be fulfilled, and we'll either have a success or a failure. I haven't drawn the failure yet, but we'll get a little bit more practice with it. We're just halfway through, so give it some time. And even then, I don't expect by the end of this lecture that you'll fully feel comfortable with this. It's just a beast of a topic. My hope is that by the end of the lecture, you'll go, at least I see the value proposition, which is that I don't have, at least in this particular type of problem, I can do it without callback hell. That's not the only reason they exist. That's not even the main reason they exist. But that is a very common pattern that emerges that is problematic without promises, and then promises help us solve it without having to go into like nesting. Yeah, we haven't seen it yet. We haven't seen it yet because we haven't only done file P1 right now. Once we see P2, P3, P4, we'll see that we could make it nested, but then there's no value. But because the way promises work, we can make it flat. We can make it like just this level only.
That actually the promise actually.
Yeah, I'll visualize this more a little bit because your question is just going deeper into what I'm going to talk about anyway. I'll clarify this a little bit more after. This diagram actually is going to go further here, so I'm going to have to find an eraser actually. Does anybody know where we could find an eraser without having to interrupt those? I guess those guys are probably on break. Yeah, I'm going to go quickly grab one if that's okay. Is that okay, guys? And then I'll talk more about promises. Any other questions that are before I go grab an eraser?
I do.
Yeah.
About the dot then.
Yeah.
That's just a method, right? So you
That's
can
just a
switch
method.
it to like anything you want, but you have to switch it down here.
The method has to exist on the object. So like if I just do dot then with two ends, it'll say that property does not exist on an object, right? Because if I have that's a good question. So if I have an object, I can't just do O dot then because it'll say undefined. It won't be an error, but it'll be undefined.
That's a normal object, right?
Well, a promise is essentially the same thing,
Okay.
right? It just has a function called dot then.
So it's like already built into the promise object.
Yeah. So now exactly. So now when I call dot then, it's I'm able to call it, whereas before I couldn't call it. It would give me an error saying this you're trying to call undefined.
We haven't run into any other object like that, have we?
Good question. That's not true.
Oh, have we?
So what's this? What is console? When I do a dot log on console,
right, it's an object.
console is an object with a whole bunch of methods.
Okay.
FS, right?
Yeah.
What is FS? It's an object with a whole bunch of methods on it,
Okay.
such as read file sync, and so on.
Right.
Same thing with fs.promises, of course, because we have a collection. In fact, low tide, right?
Yeah.
What you've been working, what you submitted,
Right.
was it exported an object with all those functions.
Right.
So a promise is similar, except it's pre-built, right?
So if I just typed in the object of promises, then I'd be able to see all the functions that's already declared.
Yeah, except it's a little bit harder to do.
Oh, okay.
Like I can create a new promise, but I'm not there yet. I don't want to talk about that yet.
Okay, sure.
But yeah, the answer is yes. In theory, you're right.
Okay.
Yeah.
The chain is not then. Like I said, run this for like this dot then.
Yeah, it won't do one before the other.
I see.
Yeah, the synchronous is very important here. The reason we know that is because this is supposed to feed into this. So there's no way this could run before this, right? It would cause a lot of confusion to us. It wouldn't add any value.
So all these, they're all waiting.
Yeah, and they kind of waterfall into each other, right? Because this one feeds into this one. So it kind of is a waterfall, right? But without having to like nest it inside.
Okay.
Just going to quickly grab that eraser. Perfect, thanks. Sure. The dot thens are synchronous.
Dot then.
It's not synchronous. I mean, a promise represents usually an asynchronous task. So it'll take time before it gets to this, right? And the way we know that it's successful is using dot then. So here we use dot then, right? Yep. No, actually, I found one. Thank you so much, though. Did you end up going to the meeting room? Well, it was a nice walk for you then. Thanks, Reza. It's Reza, right? Reza? Yep. Okay, we shall resume. Okay, so we left off talking about using multiple dot thens, one after the other, and chaining them. And the reason we knew we could do that is because p1 dot then itself, as a function call, returned another promise to us. So as it turns out, we have a promise that's pending. We attach a dot then to know when it's fulfilled. We know it's fulfilled because we console log it and we see that it has no longer a pending state. And our callback function actually returns some new data, which then feeds into, which then turns into a new promise that we can attach dot then so that we can grab that initial value, that hello from the first dot then. Okay? That's interesting, but it doesn't help us solve like additional asynchronous tasks, because return hello is synchronous. It doesn't need a callback. We don't need to go read from file or network. But what if we have to, right? What if we have to do yet another read file? Because we do. We have to do ps.read file, sorry, fs.read file, and read data p2.txt. Now we know that this returns something, right? Because we just looked at that earlier. What does this function return? A promise. That's how we kind of worked with this, because we knew we could call dot then on it, right? So here's our first call. We experimented with it. We realized that it returns a promise of type pending, of status pending. And if we're going to use that same function again, if I console log what it returns, yes, it will return a new promise to represent a new kind of asynchronous task, reading file 2, and it will start off pending. And we also know that I can return values from this callback, right? We know that. I returned hello earlier, and it fed into the next dot then. Well, what happens when instead of returning a string like hello, or another primitive like a number, or maybe even an object, What happens if I return a special type of object, which is a promise, another promise? Well, as it turns out, promises behave differently when the callback returns a promise. Okay, it doesn't just provide the promise as the intake into the next .then. This is where it becomes clever and powerful. Instead of actually just passing through that object into the next .then, I guess it does a check in the background. And it goes, oh, this is a promise that you're trying to return here. Can anybody guess what comes in? Exactly. It actually ends up behind the scenes waiting for that promise to evaluate. So we've queued up a second promise that's going to wait to be evaluated. And this .then now will take time before it executes instead of immediately, because return hello is immediate, right? Reading a file might be quasi-immediate. And so this .then will be a little bit more delayed. And more importantly, it will contain the resolution of the first promise that was returned. So let's call this P2. I'm not assigning it a variable, but essentially this is promise 2, right? And so this data actually is the resolution of P2. So let's take a look. Is that true, KV? What KV is saying, is that true? Well, when we output data for P2, we expect it to be the second sentence in the second file. So I did 2 asynchronous tasks. How much nesting? Did I have to nest again? No. I didn't have to do read file and then a .then in here. Because if I had to do another .then in here, I would have another callback, which would result in a level of nesting, which we would be back to square one with the same problem we had earlier, this callback hell. But because promises have this unique behavior where if you return a promise in the callback, it will evaluate that promise before going into the next callback. So effectively, I'm still doing a waterfall, right? Ultimately, I need P1 to read, and then feed into the P2 callback, and then feed into the P3 callback. And this is how our code looked, too. Can you guys see this in the back? I just didn't want to erase the one above. I'm still doing this kind of waterfall of data, right, before I get all of the data in the right order. But I'm not crafting my code in the same way. I'm able to actually do it all at the same indentation level using this special feature of promises. So let's complete this a little bit so we can see the full picture of what this looks like. And then we'll also talk about error handling, because we've completely ignored that subject so far, right? So this one, same pattern. Once this is done, I need to console. I guess console logging is not that important. What I need is that final doc, right? Which is an array or a string, and I need to concatenate to it. And the same will happen here. I can just comment out these console logs for now. And so now we're going to read 3. And since we're returning that promise, the next .then callback will have the input from the previous promise and what it resolves to. Okay, so this must resolve first, meaning it'll have to go read that file. If it's a large file, it will take some time. And then it will trigger this third callback. At which point I'll do the same thing. And I will do one final one, again in that callback, and return it. Make sure I return it. Because if I don't return it, I am not feeding into, I'm returning undefined, which means that the next callback will get undefined. I'll just copy this whole thing. And in this case, I have no more to read. So I push into final doc my 4th one. And then I can just, for now, console log final doc. Let's take a look. My only console log, by the way, comment that out, is the final document, just to keep things clear. And we should hope to see an array of all 4 of those sentences in order like we did last time. The one difference being that we've leveraged promises. You can just ignore this line, by the way. The one difference being that we've leveraged promises, and therefore we have one level of indentation for this problem case. Right? Pretty cool, right? So we've checked off the like, how do you avoid callback hell with promises, where you have multiple async things that need to happen in sequence. Now, to be honest, things happening in sequence in an asynchronous control flow is only one problem that surfaces with async. There's another one that can surface, which we can also talk about. I won't spend too much time on it, which is what if I wanted to read both things, and when I'm done reading both things in any order, then I want to be able to do something. Or when I want to read all 4 things, but in any order, and then I want to be able to do something. Where the sequence doesn't matter, but I do want to make sure that everything is done before I'm able to move on. We can talk about that separately. Maybe that's a stretch for this lecture. So I don't want to jump the gun. Let's actually stay here in this problem set and see if you guys have any questions about what I just did here. Next thing I'm going to do is talk about error handling. And then if we have time, we can talk about other things around promises. So before I get into error handling, any questions about this? Yep.
Like the return FSW file is returning the resolution of that problem, and that return statement won't get executed until it's been hashed.
More correctly speaking, that line 20 or line 16, these return statements, are not returning the resolution. They're returning a promise, which is a state pending. Because we know that read file returns a pending promise, because the task has just started and it hasn't finished yet. So it's a pending promise. And then it feeds into the next one, but it's not pending anymore because the next one waits until the first one is resolved. So you said that this returns a completed promise. It doesn't return a completed promise. It returns the initial state of a promise, the pending state. Was that your question, though? Yeah? Yeah, Peter? Yeah, so in terms of, we talked earlier about looping through multiple files, right? What if you have a lot of them? I think it was you that was talking about this, right? Or who was it that talked about like multiple files and having to loop through them? I don't remember. But we could do that a little bit easier here because each of those can be a promise, right? And so we can loop through them. Let's say we have 10 files. It'd be somewhat easier to do it this way. Yep.
So after the promise is fulfilled and expressed, then I can use the data inside of that promise.
Which line are you pointing to?
Like after the return, then it comes a dot then
Yeah.
of the data.
Yeah.
So that data is like the result of the.
Yeah, I'll actually comment that here. Resolution of P3, which is P3. I'm just calling it P3 in our head so we can refer to it, because we're not calling it P3 as a variable. We're just returning it right away. But in our head, that's promise 3, right? And then this one would be P4. Yep.
So is all the data still saved in our initial object that we create, or is it wiping it and creating?
It's new. Yeah, it's a really good question. Yeah, it's a good question. It's a new object every single time. So it contains just the task that you've asked it to do, not all the previous tasks or their results. Each asynchronous task, if it's associated with a promise, will kind of have one promise associated with it, right? Okay, let's talk about error handling. So we've just done this path here. But then there's another one, which is a promise can be either resolved or successful, or, as you might imagine with the red color, and we know that there can be two things, two outcomes, right? In terms of an asynchronous task. We saw that with read file in the old approach. We have an error situation, right? So this is not resolved, but rejected. Another term would be failed or errored. This is kind of the more official terminology for it, rejected or resolved. And we use .thens to kind of go through the successful flow. Our .then doesn't take in any error data. It just takes in successful data. So how do we actually detect failure? Well, instead of using .then, we use .catch. Do you remember in our old approach, I'll bring it up, we had to check for errors at every single callback? If error, then give up, don't keep going. If error on the final one, then give up. And there was just this if error handling at every single step, right? One of the nice things that happens with promises using this approach is that we don't have to put if errors everywhere. We don't even have to do error handling inside of each of these. As soon as it fails, it will trigger a .catch for us. So we just have to register a catch callback, much like a .then callback. So let's go ahead and do that. At the very end, we can say if there's an error, and only if there's an error, please trigger this callback. So this callback isn't always going to run. It's only going to run when there is a error. And the reason it's only one callback here is because as soon as there's an error, let's say there's an error here, it's not going to run these other ones because it can't. It needs to feed into the next one. And if it fails in the first step, it can't go into the second step. So promises also have this other nice feature or attribute, which is if you have a bunch of .thens, right, but there's an error at some point in that sequence, it will jump. It won't trigger all the .thens. It will jump to the first .catch that it finds, which is nice. So here, something went wrong. And then we can output error. Now, I don't expect this to actually run because there's no errors. But let's simulate one. Let's simulate maybe the third file fails to read because the file no longer exists. I'm simulating that by renaming it here or by typoing it here. It never got to printing the final document, never got to that final .then. Instead, it jumped to the callback that I registered with the .catch. And I'm able to handle that error by saying, OK, well, specifically p3 blah, 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 .txt failed to load. So notice that not only did my callback hell get cleaned up, but my error handling got cleaned up too, didn't it? And typically what you do is you register your kind of waterfall with .then chaining, and then your catch at the end, not your catch in the middle somewhere, because that would have different behavior. Right? That won't behave exactly like having .catch at the end. So one of the things I forgot to talk about my agenda, but one of the things I had in my agenda after talking about promises and using a solution with promises is I have, I guess I didn't put it in here, as a stretch to create promises. Because so far we've been using functions that return a promise. The way they return a promise is by creating a new promise, which we can do also. You won't be expected to do this too much early on. You'll be using more other libraries that give you promises, so you'll be consuming promises. There is one activity today, near the end of today, that has you practice creating promises, just so you can see and relate to the other side. But I would say it's quasi-advanced / unnecessary to learn that at the same time. Right? So we kind of defer that learning a little bit. Yes, you play with it just to be able to relate to it, but you aren't going to be expected to do that on tests and things of that nature, right? Yet. Now, by the time you graduate, you'll hopefully be somewhat comfortable with promises. Like you'll probably not fully be comfortable yet. and maybe even creating promises, right? Before I move on to anything though, any questions about the stuff that I've covered so far with the dot then chaining, the dot catch, or anything like that? Oh, you know what we didn't do? In the dot catch, we didn't console log what P1 looks like. It's a fulfilled promise. And it's completed successfully. But there's an error. That's interesting. Anybody want to know, anybody guess why P1 looks like it's successfully completed even though we have an error? Somebody other than Peter? Why did P1 look successful but we have an error? Exactly. The error didn't happen at P1 or even P2, which I know is not a variable, but like the second promise over here. The error happened on this one. So if I did store that into a variable, like temporarily, I would be able to console log and see that it wasn't successful. And we can do that. Let's take a look. So instead of returning it, let's do const p. Well, let's assign. I'm going to have to put it out here so I can see it. Let p3 and then p3 equals. And this is the one that's going to fail, right, because of the file name. And so here, we can say, well, what does p3 look like in the error situation? Oops, I screwed it up. I got all of these weird, this is a good, actual good talking point. I didn't intend for this to happen. But notice what just came out. I got an error. I mean, the experimental stuff we're ignoring. But I'm getting an error saying, or a warning, saying unhandled promise rejection warning. There's a promise rejection happening that you're not handling. And this is the rejection. This is the failure that happened. And the reason, it's an obscure one, but the reason it happened is because I forgot P3 is going to fail, right? And I forgot to like return P3, which means I'm not attaching any callbacks to P3 right now. So I need to return P3 here. And we can see here that what I was trying to do was console log P3, and look at what it says. Specifically, that part. Rejected. A little bit of visualization I think would be useful right now. If we look at MDN's documentation for what is a promise, and it's a good review as well, let's do a little bit of that. The promise object represents the eventual completion or failure of an asynchronous operation and its resulting value. Now, they get directly into creating a promise, which I said we would do less of, so we can ignore this. But there's the dot then on a promise, right? So here's a little bit more of a description from MDN. It is a proxy for a value not necessarily known when it's created. So the promise is created. It doesn't know the value, the resulting value, because it hasn't made that file system call. It hasn't made that network call yet. So it allows you to associate handlers or callbacks with an asynchronous action's eventual success or failure. That's your dot then and dot catch. So I would say after lecture, spend some time reading this or other documentation on promises. And of course, we provide you with some as well. There's even a video on promises that you can watch later today. The one thing, okay, so this is the diagram I wanted to show you. So I didn't fully draw this out, but I don't have as much horizontal space. But you saw that I drew out a promise in pending, and then, you know, it's either fulfilled or rejected, right? And actually, the terminology I use is somewhat incorrect. Technically, this is called settled. So the outcome is that it's settled. And it's either settled by being fulfilled, which is successful, or resolved, same thing. Fulfilled, resolved, successful, right? Or it's settled by being rejected. So that's what they're showing here. Yeah, you can, but we're going to pretend that pattern, we're going to pretend it doesn't exist, just to keep it easier to learn. But yeah, you can use dot then to grab rejections as well. Yeah.
But then in this case, we're just using dot catch to
Yeah.
return an error or something like that.
Yeah, well, specifically catch the error, right? Using a callback, of course. So once that's settled, we can trigger additional async actions, which can then return another promise, which can then have additional, like it's basically going to continue on until as long as we want. Right? This waterfall that I was drawing earlier. Now it's 11:32. I'm deciding, so maybe what I'll do is I'll do a little bit of an exercise on promise creation, but I don't want you to get too worried about that right now, right? I think work on the skill of like working with and consuming promises, and then separately work on the skill of being able to create functions that return promises. But I'll just show you so that maybe you'll be able to relate to kind of how they work a little bit more. So imagine that we are writing a function which is asynchronous. Now, a summing of two values is not asynchronous. You just do a plus b. But let's assume that summing is really expensive and we're going to do it over time. So write a function sum which takes in two numbers and adds them, but simulate a delay. So it's going to be asynchronous. And its async behavior should be promise-based instead of using callbacks directly. Okay? So normally, I would maybe have a callback function that would be triggered when x plus y has been calculated, right? I'm not going to do that. I'm actually going to not accept a callback and return a promise, right? So this is the other side now of read file and actually how that would be implemented by returning a promise. So we would actually return a new promise. Whoops. Like that's essentially what we have to do. This whole function has to return a promise. Agreed? If that's how we're going to implement it. Now, what does a promise actually contain? It contains two possible outcomes. It can either be resolve or reject, right? And so what the promise API takes is two additional functions that we can call to say whether it was successful or failed, so that we can change the state from pending to one of these two states. So this is a callback function in and of itself, right? Because it's an async operation, we want to make sure that it happens like later. And then the other thing is, in here, we're going to decide to call resolve or reject. These are functions that are given to us by the promise API. The promise object itself gives us these two functions. And you'll see that in MDN's documentation as well. We can call those whatever we want, like success, fail, but the common names that we want to give these local variables is resolve and reject. Right? Resolve and reject. So in our case, we're just doing a simple x plus y. And we need to return this value. But again, it's not synchronous code, so we're not going to just use return. Return here will not do much for us. We need to actually resolve with this value. And so here's the promise that is returned. And it will, when you use a .then on it, it will give you the actual final total. You see how the pattern, we're not using return here, just like with callbacks. And we're not just calling any callback that's passed in. We're actually returning an object that then takes additional callbacks, which it then resolves. So it's a little bit more confusing and complicated, but not too many lines of code either. And let's say there were certain situations where we didn't want to return the result. Let's say if you pass in, I don't know, in this case, if you pass in anything that's less than 0, then it's not going to sum them for you. I don't know. Let's just come up with that arbitrary definition. So here we would have a check. If x is less than 0 or y is less than 0, we want to fail. Otherwise, we're ready to do the computation. So this would go in the success. And then the fail, as you may be able to guess, is to call reject. So let's actually call this function. What do I expect P to be? Promise. Because what is sum returning? A new promise. And what's interesting is that it's not pending. Did you notice? I expected it to be pending. Did you? Probably, because that's what we've been dealing with before. But it's not pending. Any guesses as to why it didn't start off pending? That seems bizarre. We're told that all promises start pending, yet as soon as I console log it after creating it, it's resolved. Yep. Yeah, this particular promise is not doing anything asynchronous, so it's actually running in the same process. There's no reason for it to defer that particular task. We can simulate that though, right? We said here in the problem that we should simulate a delay. How do I do that? How do I simulate a delay? Set timeout, exactly. So I wouldn't put the set timeout outside of the promise because I want to return the promise immediately, right? With the state of pending. The set timeout is actually going to be inside here, inside the callback that's within the promise there. I'm going to move all of this stuff into here. And the set timeout, let's say, is 1 second. So I have my set timeout, which contains all the actual logic. It takes a while before we can do that sum, for whatever reason. Now when I console log promise right after it's been created, it will do what we expected. And notice that there was a second before it finished, when it ran. Right, because it's still doing that task behind the scenes. It's still waiting for that set timeout to finish. Just like before. And as you might imagine, I'm going to use a dot then. To say, right? And 7 is being actually passed through because we resolved with that value. And I can do the same kind of chaining here, right? I can have this return an additional sum. And then do a dot then out here, just like we did with a read file. I would probably want to nest this like this if I'm doing multiple dot then so that it's easier to read. Now what happens if it's an error case? Let's try it. Let's use another example where we pass in a 0 for one of the values. In that case, it will trigger into here, and it will actually not trigger the resolve, but it will actually trigger the reject. When the promise is rejected, it will not go into dot then. at least in this way. And it will instead, right now actually, it will issue a warning saying that I'm not handling the rejection. Oh, it has to be less than 0, right? Whoops. So -1. You see these unhandled promise rejection warnings? It's saying you probably screwed up there because error handling is important. You have a promise that's rejected, you're not handling it, right? So we're going to need to do a dot catch here to deal with our error. Whoops. Reference error is not defined. Right. You saw that I'm not using the right variable name here. There we go. Any questions about this stuff? It's probably a lot to kind of take in, and you've kind of seen both sides. Maybe this is going to help you understand what FS read file is actually doing, the promise version of it. Behind the scenes, it's doing return new promise, and then doing the behavior that it was already doing before, which is to read the file. You had a question? What do resolve and reject do? They are transition functions, which is just a fancy, I just decided to call them transition functions, but they're essentially functions that we're given that help us go from here to here or here. Because ultimately, as the function that's returning a promise, it has to know how to update that promise. So these are actually callbacks. That's why I can call them. Right? So this is the resolve, and this is the reject. So the FS read file internally is going to call one of these, just like we are. So anytime we create a promise, ideally we have both of these callbacks, and we use them to change state from pending to one of these two states. Not both. It won't like that very much. Once a promise goes from pending to settled, it cannot go back to pending, and it cannot switch. So it's basically one way and point of no return, right? Because once I give you a task, you either got it done or you didn't, and that's the end of that particular task request, right? It's a long enough awkward pause, no questions? I'm done in terms of what I wanted to show you, but a couple of warnings. One is that, well, the main one actually, is that there's this new feature in ES6 called async await, and you'll find a lot of documentation out there for new libraries that will potentially just use callbacks like we're used to, offer solutions with promises like we will get used to as of today. But then as a third, more modern approach, they'll give you this async await option as well. So this is a new feature in Node. Forget which version of Node exactly, but essentially an ES6 feature, I believe. Which I'm not going to show you the example code because well, MDNs is not so good. Maybe W3 schools. I don't want you to actually look at this. It still uses promises. And it actually makes our lives easier where we don't have to even worry about callbacks at all. Which is like, wow, that we're doing async stuff without having to worry about callbacks. That's awesome. but behind the scenes promises are being used. So while it does make our life easier, if you don't understand promises, it's going to be hard to work with this or debug it if things don't work well. So ultimately, for the majority of the duration of the bootcamp, because promises will take some time to solidify, I don't want you to take this easier approach ever in this bootcamp until final projects, where you then have the ability to decide if you want to use promises still when you're making an API call or whatever, or if you want to use this more newer feature in Node, which is building on top of promises. So just a note to you is ignore documentation or suggestions to use async await when you're looking at new libraries. Because if they are using async await, then they should be able to support promises as well. Because that's what async await is built on top of. So just be wary of that. And the other thing I wanted to show you before we adjourn is, you know how at the beginning I said, well, promises solve many different problems. This is just one of them. Let's take a look at some of the other ones, but we won't go into detail in them. So if I was to look at promise on MDN, you'll notice that there's a couple other functions that we can call instead of just .then. One is promise.all, which is really, really nice. It's basically saying, pass in an array of promises, and a single .then will tell you all the values that they come back with. So this is really handy in the scenario where you don't need to do one after the other. You actually, why wait for P1 to be finished before P2? We don't need the data in order. They're not dependent on each other. We just need to make a whole bunch of requests for these files, and I want all the data. And instead of doing them one by one, which is slow, why don't I just tell the operating system to read all of them at once? It's way faster, right? So, of course, it's a different use case. But we can just say, go read P1 and P2 and P3, and let me know when you have all of the data, X, Y, Z. And so this will actually trigger all three of these at the same time, and it'll be much faster. But of course, you only do this for when you don't have data you don't have dependencies between each of those things. You don't care about the order that they come in. Now, what's nice is that the data, of course, will come back because if we give it an array of 3 promises, it will give us an array in the same order of the values. This would be much harder to do with callbacks alone. You'd have to have them at the same level. But the problem is at each callback, you don't know when it's finished running, when all of them are finished running. So you need a counter to count, let's say, 3. And then when the counter reaches 3 in any of those callbacks, you don't know which one it will actually hit 3 in. Then you'll be able to do the next thing with all 3 of those pieces of information. So it actually becomes a really complicated, not really complicated, but kind of annoying to do this without promises, where you run a whole bunch of asynchronous tasks at once. Another really nice one, .race. What if you actually need to make you need to make at least one async call, but you don't need to make other ones if the first one is really fast. So you actually race a whole bunch together, again, using this array option, and say, go do these 3 things together. Whichever one comes first is the one I care about. Because maybe you're trying to get data from similar data from all 3 different, search engines. And you really want the one that's fastest to come back because the user's waiting for data. Right? You would race 3 different network requests to maybe Google, Bing, and a third search engine, DuckDuckGo or something. And you would only care about one of the results, the fastest one. So that's another cool thing that you can do with promises. OK. Any questions about this or error handling or promises or even callbacks? Let me bring up the code that we wrote in the end. It's this here for creating promises. or this one here for the more important stuff, which is working with promises.
So is that P1 wrapped? Is all of that wrapped in P1?
Yeah, that's actually a good question. It seems like I'm calling .then the second time, and the third time, and the fourth time on P1. But the truth is, P1 only represents the first file read. So, because it's nested in this way, or it's indented in this way, it looks like this is on P1. But it's actually not. And if you recall, this whole expression returns a new promise. And then this expression returns a promise. So each .then is actually on a new promise. We're just not assigning it to a variable each time, because it would just be too verbose. We could, but it would just look it would be harder to follow. But yeah, the only time where there's only one callback attached to P1, and that's this one. And then the other ones are like essentially on imaginary variables that aren't created, but they're new promises.
So at the end of P1, you're returning to read P2, and then the next .then is when it's handled off to that, or the return is handled off to .then for the second one.
Yep.
And within the P2, you're handing it off.
That's right. This is why it's a little bit more confusing to learn this stuff compared to traditional callbacks, because there's more control flow stuff happening here, right? Not only is there a new object involved with states, but there's also like this object's just being created for us, right? This promise, we're not creating any promises here. We're just getting them, right? And we're just tying into this red or green situation. Any other question? That was a good question. Yep.
So when you create a promise, you don't need any like libraries or anything.
That's actually a good, yeah, that's a really good question, and I forgot to speak to that. This particular keyword here, capital promise, if I just start up Node, I can start using it. This wasn't always the case. They were added in, again, I don't remember when, but a few years ago they were added in as a native thing in Node. But before then, the idea of promises have been around since the 70s. Like it predates, the internet. So that's just because it's a design pattern. Like it's how we can potentially deal with asynchronous things, which existed even before the internet. But Node implemented promises a little bit later. So what happened was in the Node community, there were these other libraries that actually implemented promises that were being used quite heavily until Node finally implemented promises. And then most libraries have started moving away from using those libraries and have used the native promise. So that's another thing I wanted to speak to and I forgot. So good question. You may come across their names. So there's, if you just look up Node promises or promise libraries, there'll be a bunch that come up. One is called Q, just the letter Q. The other one is Bluebird. There it is. And there's a couple others as well.
So this was made in like back in 2017. I was just seeing like the creation results.
For where?
I think you scroll down. Like people were asking about like.
Yeah, but I don't know if that. Yeah, we would have to do a little bit more research to figure out exactly which year or which version of Node it was added in. I'm not sure. Might not be 2017. It sounds like it would have been earlier, but I'm not sure. Any other questions? They seem to be bringing up good conversation. Yeah, nice.
If you're not using Node, if you're using JavaScript on like a web browser and that, would you still be able to use promises?
Yes. How would you go about finding out? So more about the approach, right? Yeah, I would just open up any Node, any browser terminal, open up DevTools. Right? In here, I have the console tab where I can type in JavaScript. right? Things like set timeout and all that. Wonder what this does. Nice. I can access promise. And so, at that point, you could go ahead and do more experimentation, but that's a good way to find out, does this thing support promises or not? And yes, because it's part of the JavaScript specification for ES6, browsers also have to actually implement it. Awesome. So it's 11:57, good timing. I'll send out the notes in the next 5 minutes. They'll be the same notes before, so even if you scroll down in the lecture, you'll see my notes anyway. And that'll include the code that we wrote together. Cool, cool? Thanks, everybody. Enjoy. Cheers.